Chemistry, and basically we are going to look at organic chemistry. So the organic chemistry, we start by finding the family of the compounds. So the family of compounds are called the homologous homologous series. Now homologous series uh, have the same they have the same functional groups. That's a homologous series. They do have the same functional group. Now the functional group is a chemical group or a molecules that you have. So these are molecules that have the same characteristics chemical reactions and properties. Now we look at the homologous groups that we have and their functional. So we can call this series the homologous series, and we have got its functional group. So we are interested with its structure. The functional group, we have got the structure of the functional group. So first of all, we start with the homologous series called alkanes. The alkynes, the functional group of the alkynes is a single bond. The single bond we have. So alkenes are single bond, and the structure is just a C like this. This is the structure of that. So basically, when you have an example of an alkene is methane. And methane is where you have this. This is an example of an alkene. That's the first homologous group. So it's an alkyne, and it's single bond functional group, and the structure is the C with the 4 covalent bonds. And then an example, we have got methane, but we've got ethane, propan, butan, hexane, heptane, octane. All they are. So we go to the second one, which is called the alkene. So we have got the alkene. The alkenes, these are double bonds. And the double bond we have is like a C, double bond C, and then it's 2 like this, right? You can draw anyhow you like. So the likes of, we have an example which is ethene. Ethene is a good example of that. I'm not going to draw it because it's going to take my space. And again, I will just erase this one here because I will need to draw this in detail in the next section when I'll be talking about these homologous one by one. So ethene, and mind you, you can see that the suffix is ene. That one is ane, right? The third one is alkyne. If my pronunciations are not proper, please forgive me. Just to take the way I am writing. Alkyne. So this is triple bond. So this is triple bond, which is a triple, 1, 2, 3, C, and then. So we have the likes of iron like this. You can see the difference here is the suffix. After that, we have got alcohols. Alcohols. The alcohols, we have the functional group of an alcohol is called the hydroxyl group. So it's a hydroxyl group. So the hydroxyl group is a stroke OH like this. Where an example we have is ethanol. Ethanol. Now we have got aldehydes, number 5. Aldehydes. Aldehydes, the group is called carbonyl group. Carbonyl group. And the carbonyl group is actually a C O at the end, and then we have an H here. That's the group we have called aldehyde. So I'm saying the hydrogen, the oxygen is at the end of the group. Let me just specify here that the oxygen is at the end of the group. The oxygen is at the end of the group. Okay, let me just specify. The oxygen is at the end of the group. The oxygen is at the end of the group here. It's at the end here of the group. Now, why am I saying this? Because you are going to see the ketone. The ketone has got a story behind. So we have got ethanol, or we can have methanol. Ethanol or methanol is at the end of the group of the aldehydes. Number 6, we have got ketones. Ketones are also carbonyl. Carbonyl group. Carbonyl group. And this one is also a group. Carbonyl group. But what's different is the carbonyl group is in between, the oxygen group is in between the chain. So it's in between the chain. I will need my red and say this one, this group here, in between chain. So we have the likes of, on the ketones, we can have the likes of propan 1. Propan 1 is also an example of a ketone. Then we have number 7, which we call the carboxylic acid. Carboxylic acid. Now, the carboxylic acid, the group is called the carboxyl group. Carboxyl group. And the carboxyl group is quite easy because it has got a double bond on the oxygen and an OH here. That's the carboxylic group. Then we have the likes of ethanoic acid. Ethanoic acid. Now, we also have the 8th group, which is called the haloalkanes. Haloalkanes. The haloalkanes is an halogen atom. The group is halogen atom. Remember, the halogens are in group number 7 on the periodic table. We have the likes of fluorine, chlorine, bromine, iodine, etc. But normally you are going to find fluoro, chloro, bromo, iodo. So this is iodine. So it's normally given the atoms, I should have put this here because it will be just a C with the X. Then the X is representing any of the halogen group. So we have like chloroethene. So it's chloro ethan. So we have the likes of chloroethan. And then, yes, so basically this is the homologous groups. So we looked at all the families. A homologa is like a family. So the family has got different groups. So please like my video channel and subscribe. I'm going to put more of this in the next. You'll see the alkene where I will describe one by one the homologous group. Thank you.